In this demo scenario, we'll walk through how Apstra Cloud Services helps quickly detect and resolve issues impacting critical workloads in the data center. In this case, we have some critical virtual machines running our CRM and GitHub applications. The scenario begins with a notification from the IT help desk informing us that users are reporting problems with the CRM application. The network team knows the importance of this system and must quickly investigate this issue. The affected users are trying to reach IP address 1070.70.79, but haven't been able to access the CRM application since 8 a.m. The enterprise IT team has already ruled out Wi-Fi and access point issues. Everything looks fine on that end, so the focus now shifts to the data center. As the network admin, the first step is to enter Apstra Cloud Services. Once logged in, the dashboard provides a high-level view of the data center, showing inventory, current network status, and any detected anomalies. On the right side of the screen, the anomalies panel displays a list of ongoing issues, along with impact analysis widget that highlights what part of the networks are affected. The admin suspects the anomalies may be related to the CRM issue and decides to confirm whether the client IP was actually reaching the data center. Navigating to the service-aware screen, the admin opens the service topology view to examine client connection attempts during the reported time frame. The CRM application is running on port 8069. Clicking on the CRM tile reveals the service topology, the port it's running on, the client IPs attempting to connect, and the VMs and compute resources involved. The admin confirms that the client IP mentioned in the problem report indeed tried to reach this service. Next, to check for correlation with the anomalies, the admin opens the impact analysis screen. By selecting the affected time frame, a visual graph displays service impacts in the 15-minute intervals, helping narrow down exactly when the issue began and which services were affected. In the 7:30 to 7:45 a.m. window, no issues are found. But from 7:45 to 8 a.m., anomalies appear, specifically a link status mismatch. Expanding the graph shows detailed host data. The mismatch appears on Leaf2 FX04. This is directly connected to ESX01, the host running the CRM VM. The anomaly report confirms service impact, showing traffic from 1070.70.79, the same IP from the initial client report. To verify the issue from the virtualization side, the network admin contacts the VI admin. He logs into the vSphere client. There is a network connectivity lost alarm and it's active. Checking the alarm details, the VI admin confirms that the distributed virtual switch ports lost connectivity due to a physical link being down. This affects the port groups tied to the CRM VM. The outage outlines perfectly with the time of the reported issue. The VI admin knows that both the CRM and the GitHub VMs are critical systems. Since the CRM VM is impacted, this issue is escalated and prioritized. The network admin logs into Apstra, navigates to the relevant blueprint, and confirms the presence of a generic system connectivity anomaly. This indicates that the interface connected to the ESXi host is down. Further investigation reveals that a disable interface configlet has been applied. This is what has disabled the interface. To resolve it, the admin removes the configlet, brings the interface back online. This change is committed to update the interface configuration. Afterwards, they notify the enterprise admin to check connectivity to the application. Initially, it's still unreachable, but shortly after, the client is able to connect. They confirm that the CRM application is now accessible and functioning properly, and there are no issues navigating through it. We've demonstrated full end-to-end assurance with Apstra Cloud Services, starting with the user's issue, identifying the root cause via anomalies in the fabric, and resolving a network connectivity loss that was impacting a critical VM in the data center.